Test. Yeah.
Okay. All right, we're gonna start again. So we've done servers. We've done a server at least. We did the proxy server. We did the uppercase server. We're going to now do clients. So previously we used endpoint dot. Okay, so this is a client written using imperative Python with socket. That was the first client. So we can do this. This is big difference here is it's client from string instead of server from string. And this is reusable as well. So this example is wrong.
You wrote it.
I can't believe I wrote that. Anyway, so the important thing is that there's a close bracket there. And you can reuse that to connect to the same server multiple times. So you can do .connect, .connect, .connect with different arguments or whatever you want. You see, this should actually be returning a value and then doing that value .connect factory. But in general, you use client factory for clients or a subclass of client factory. You don't have to. You can just use factory, but client factory is preferred. And if you run this, you'll get a traceback because wrong number of arguments. And this is just like the original server that we wrote, which is, it connects, it doesn't do anything. If it receives any data, it throws it away. Protocols for clients have exactly the same callback functions. So connection made, connection lost, data received. The factories are more or less the same. Client factory.
Sending data is also just self-transport, right?
In fact, you can use the same protocol for both the server and the client if you've got a symmetric protocol. Yeah. So let's use a client that will connect to the uppercase server. So if you've got uppercase.py, run that, just so it's running in a different terminal. This is simple client.py. It's in that bundle, and we'll run that. So run that now. In this example, you see it's doing client from string, endpoint equals client.string, creates a new factory for each one, and sends it. Now, for every connection, we're creating a new factory. This is normal. Because the factory is what has information about the connection once it's established, and so if you reuse the same factory, it's going to have the same attributes, and so it's hard to do unique things on each connection. Say if you wanted to connect 5 times and send 5 different pieces of data, you create 5 factories, and each factory just contains one protocol. And after the connection is lost, the factory gets thrown away. Run uppercase server, and then try out simple client. Simple client requires command line arguments, which is the host and port is the first argument, and the data to send is the subsequent arguments, and it will do multiple connections. Run that now. This is very similar to the original threaded and non-threaded clients. This will asynchronously do multiple connections in parallel. So for instance, if the server takes a long time to receive connections, or the server doesn't respond immediately, this will queue all those connections up simultaneously. All right. This is an example of it running, and so you see it's sending A, B, C, and D. So it's establishing those connections, and in this case, it's actually come back with D, A, B, C. So D connected first. And that sort of stuff can happen quite easily. There's no guarantee of ordering. So the data is returned in random order, i.e., it's all happening more or less simultaneously. Annoyingly, we can't access or return data. We'll talk about that in a bit. The loop never stops, and there is a question about performance. The first question is, how do we gather the results? How do we actually sort of say, I want to do 4 queries, but I actually want to match up the request to the response? We have a thing called deferred list. Now it's also in the deferred module. Where's deferred list here? Okay. First of all, let's just do deferreds. So we're just using a client factory and addressing it with a few attributes, text and deferred. The simple client 2, you can open this code on your machine and you can run it. This will create a deferred, add a callback to it, this thing for printing the response it received, as well as information about the request, because we're passing the extra parameter there, which is the request. It will create the factory and give the deferred to the factory. Because we've given that deferred to the factory, the protocol can access it. It accesses it there, so self.factory.deferred. So in this manner, we've actually created this full sort of connection between the request we've made and the response that we get. If you were writing an API, you would wrap this all up in a function, so you end up just having, get data from the uppercase server and arguments the server address and the argument, and it would create the factory, address it with deferred, add the callback, return that deferred. In this case, we're doing it all explicitly. So the important things are you create the deferred, you pass it around, and then in the future, this is the most important thing, and you do this a lot in clients. Callback. Callback fires it. You can only have the callback called once. Callback starts the callback chain. We call the callback here when we receive the data. Sometimes you have a whole list of deferreds, one per request that's made. So you might have an entire list of them, and you pop them off the list in order to get the results in order, that kind of thing. But the important thing is you only call them once. You generally throw them away after you've called them back and lose the connection. Right. This is simple client 2. Again, the results are in random order, but you see that this callback that we have here, got data, is linking up the request and the data. So the response for B is B, the response for A is A, the response for C is C, the response for D is D. It's all linked up. Yes? No, can you run down with the mic? Oh, okay. Sorry, he wanted some help with some code he had. All right. The other problem we have here is the loop never stops. When you're writing a client, you always need to actually shut down the event loop. Otherwise, it kind of gets boring. So we have a deferred list. Deferred list is something which takes a bunch of deferreds and fires when all of them fire. In fact, it's very customizable. You can say fire when any of them fire, fire only when they're all successful, otherwise fire the back, blah, blah, blah. The default is that it fires with true or false depending on whether or not each one was successful failure and the value that it fired with. So a list of tuples, 2 tuples. This is an example of deferred list. So you got I'm feeding back. So we've got 2 pages, several pages. We create a list of all the deferreds, call get page, add them all to the list, append it to the list, and then we create so this is a normal list, and then this is a deferred list that we pass them all to, and then we add a callback to that to say when everything's finished. Simple client 3 demonstrates deferred list in use. So here again, we create a list of all the deferreds, we append them to the list, and when all of them are fired, we actually call reactor.stop. Run that now. Simple client 3. Same way as simple client 1 and 2. So again, requires that you pass the host and port to connect to and blah, blah, blah. Talks to the proxy server, I think. Is it proxy server? Can talk to the proxy server. Here's an example. It's exactly the same as the previous one, except you see it's returned us to our prompt the moment it's finished. Performance. Simple client 4 is much the same, except it actually says how long it took. I'm not Oh yeah, so in this example, he's done it against the proxy server, and you see it's doing them all simultaneously on the proxy server and seeing how long they took. Making 4 connections to the proxy server and then timing them. And then if you run this twice against your caching proxy server, you'll see it almost being instant. Okay, so the next exercise, exercise 3, I'd like you to write a HTTP client, a real HTTP client, not using getPage, but actually implement getPage. So you want to send a valid HTTP request. That's what a valid HTTP request looks like. If you're going to hit something like google.com, we do recommend a user agent string. You want to send the data, receive the data, and have it work like that. I think you might actually find a http.get.py in the examples, and you can fiddle around with that and see how it works, or you can write it yourself. Go for it. And any questions? Hands up. What version do you want? You use 12.1. This code all works on 12.1. I've never used it on 12.0. No, I thought it was too.
Well, it works for everybody else.
No, if you have to do that, you have to do that.
So apparently, if you're using a slightly older version of Twisted, and the sample code uses positional TCP client endpoint, so that's TCP:/host:/port. Apparently, that only works on really, really, really new Twisteds, which surprised both me and Steven somewhat. If you have an older version, you can use it with a keyword version. So in front of the host, you put host equals. In front of the port, you put port equals, and then it works even on older versions, apparently.
Sorry about that.
That's fine.
So one of the important things here is you don't have to work out when the response is finished. You know it's finished because the connection closes. So you fire the deferred and the connection lost because you know the connection loss signifies the end of the information. And I recommend using line receiver. Actually, we didn't cover that. Line receiver has a method called sendLine. Which you can use instead of self.transport.write. It's a convenient way of sending a bunch of lines. You just do send line, and then that information without the line ending, and it sends it with the delimiter. It's convenient. You don't have to use it. You can use self.transport.write, and it just works. Are you using 12.0?
Yeah.
Okay, so if you're using 12.0, to do a connection, you have to figure out where your terminal is and start one. You have to do TCP:/host equals localhost port equals 8000. It's only if you're using Twisted 12.0. Apparently, you can't do the shorter version, which is command not found. TCP:/localhost:8000 is the 12.1 version. Sorry about that. I didn't actually know that. I'll leave this up because it's slightly more useful.
So in new version of Listen apparently that no longer is the case. Because
Tried
they...
upgrading, but I'm running Mountain Lion.
Okay.
Cougar. It's technically the same cat. And it's the only one we can guarantee you to talk to a server, which is an awful lot.
True.
Although that is something we might revise. You know, for a postfix server or something.
Yeah, okay. Finger.
Never really can. A number of times I've revised that tutorial and just not published it. Can I get a show of hands of people who've basically done this, or do you want to continue going? Anyone finished? A few more minutes, right. This is the sort of thing that's really easy to test if you just import your module from the REPL using python-m twisted.const.standard.io. It's just much easier to test that your code works, and then you can use reload to reload your module once you edit it. Just as an idea. It allows you to do it interactively and see when the deferred fires. Unit testing. Stirring point and a protocol. Because you don't make it at factory. And you already know you don't need factory.
It might be easier for, especially if you're doing tutorials.
No, this is for running code. It implicitly puts on, it gives you a factory with a on it. And so it returns the third on the actual file, the third on the protocol.
Right.
Protocol instance, of course. Maybe some arguments which get passed through the internet of the protocol.
Good work. I just keep running my unit tests. Write code until the unit tests pass.
There's just so much boilerplate around the function. actually know how to use it anymore. My SSH keys are that tricky. I know some versions of the point I can get away without it anyway. Okay, well, I'm just going to move on and show a example of this working. So this is a GET protocol, and I've just got a method called GET here, which takes a host and path. It's a bit annoying. You've got to parse. Yeah, I'm not using EuroPython here. I've just got the host and path on the parameters. It sets the host and path on the factory, creates a deferred. I just did this on the line before, so it's so I don't end up with a huge long line. And can't believe myself. This should be .connect. I'm fixing that right now. I'm sorry, guys. This example should be .connectf. All right. Sorry. Yes? Yep, that's exactly it. And it returns f.deferred. So this will connect. When connection is made, it will write all the stuff. When data received is called, it will append everything to a buffer. I'm actually using protocol, not line protocol. And on connection lost, we'll just call deferred.callback with string.join the buffer. If you're really fancy, you do something where it pipes it through W3M in order to strip out the HTML, but so that's HTTP get.py, which might even work, I don't even know. So when you're writing clients, you've got to know what's written by either end. You write the protocol object, create the factory, set the instance variables. That's the general pattern you use. Access some variables from the factory, from the protocol, and connect the factory to a host and socket. Host and port. When you've got long connections, connections which, say if you're running an IRC bot, for instance, it's the sort of thing you want the connection to always be up, and if it gets disconnected, to reconnect. Reconnecting client factory is what you use. It also has exponential backoff, which is useful when you're on conference Wi-Fi and you won't be able to connect for minutes at a time. So it connects until, and then on the next successful connection, you call a method which resets the delay. Read the API docs. Reconnecting client factory is similar to a client factory, but for reconnections. I recommend you use it for things like those cases, IRC bots. Is there anything else on the internet uses long-running connections anymore?
Besides IRC bots? No.
No? Okay, good. All right. Everybody likes to write an IRC bot, so I mentioned that. Twisted Web, Twisted Web is... what was I thinking when I wrote this? Twisted Web is the sort of thing that you use if you want a web server. So we had a web client earlier, this is a web server. You generally don't really want to use this in preference to Django. Django is a much more mature web framework for doing webby things and has great templating and everything supported and works on WSGI. Twisted is the sort of thing you use if you want a web server which also talks XMPP and has really long-running connections and has all sorts of other networky infrastructure in it. Like if you have an existing thing which talks network protocols and you also want it to have a HTTP status page, this is exactly what Twisted Web is good for. This is an example of, you can run this, web2.py. If you run this, it will create a page with two resources. the blank page is the index, and the sub URL page is called returns the page, and it returns hello in a page. It works. This only supports get, because that's a render get method that it supports. This clicker is terrible. Get a better one for me next time. So you subclass resource, which are pages, and the root is also a resource. So resources have children. You create a site, and you listen. And of course, it's got the same typo on it. So I don't even know if the example you've got, not connect, listen.
So one of the reasons that you probably want to use a real web framework if you're writing an actual website is that Twisted.web, as it currently exists, is one of the oldest parts of Twisted. And, like, for example, it doesn't really do deferreds. You can use deferreds, but you sort of have to hook it up manually, and there's this weird thing like not done yet that you have to return from a render method if you're where it really ought to be a deferred. We're working on that, but right now Twisted.web really it's well, like Steven said, it's for things like status pages.
Yeah. We're going to be using it here. We're going to connect up a few things and have a web page and other things involved. So here's some example. This is a persistent connection. This is using reactor.calllater, which is like JavaScript set timeout, or what you'd use in preference to time.sleep. And this just basically writes A, B, and C to the output. If you actually run web3.py and then do that curl, you'll see A, a second letter B, a second letter C, a second letter will disconnect. You return in this example not done yet, which is from Twisted Web Server, to say I'm not actually done. Wait until I call request.finish. So call later, by the way, takes callable as the first argument, and any arguments that you want to pass that callable as the subsequent arguments. This is another example of an actual practical example. This is Web3B. It calls getPage, Twisted Web Client getPage, or the one you wrote from HTTP get. And you add a callback to that request.write. This is essentially getting the page and returning it. This is an actual web proxy server. Doesn't cache, but could. And then finish the request afterwards. In this case, we're using a quick lambda instead of defining a function, throwing away the response from the request.write, because whatever request.write returns is what gets called past the next callback. We throw that away because we don't care. We're just going to finish the request at that point, and we're going to return not done yet. It's actually a bug here. I'm going to cover this right now because it's actually quite useful to know. When you have things like you want to stop the reactor when everything's done, or you want to finish a request when everything's done, add callback is not the right method. You actually want to add callbacks, which adds a callback and an errback simultaneously. So it doesn't matter if an error or a success happens, you finalize.
So add both. It means take one thing, add it as both a callback and an errback.
Oh, sorry, I meant add both.
Right. So and add callbacks is a way to add a callback and an errback at the same time. There is a difference between add callbacks, callback errback, and add callback, callback, add errback, errback. But we'll see later what that is. Okay. It usually doesn't matter.
Sorry, add both. So I actually recommend you use add both for any reactor.stop or request.finish. That's a side note here. I just wanted to point that out. So what we're going to do is a key value store. So this is a key value store. So it's got a store, get, set, delete, a cache. We're going to upgrade that to make it keep stuff for only 15 seconds, and that's the next exercise. This is an example of actually how to schedule things with call later. So this in 5 seconds prints, and after 6 seconds stop. That's a second example of how to, you can run these sched1, sched2.py. Print something, actually abort a delayed call. So in this case, abort actually calls delayed call.cancel. Okay, sorry. This isn't an exercise, this is an example. This is a key value store, which after 15 seconds deletes a key. Now, let's have a look at this. We have a store, and we have a list of timeouts. This is a dictionary of timeouts. When you get something, you just want to return whatever's in the store. And that'll raise a key error if it's not there. Set cancels the timeout for the key, because otherwise you're going to invalidate a cache which has been refreshed. Sets it in the thing. It also sets a timeout for that key. 15 seconds, call self.delete that key. And you can see that self is, of course, because it's a bound method, self is passed through, the key gets passed through, cancels the timeout and deletes it out of the store. And the cancel timeout removes it if it's there, otherwise returns none. And here we say if it's not none and it's active, then cancel it. Self-explanatory. So we want to expose keyvalue.py. So we're going to be importing this and using key value store on a custom protocol. Maybe some kind of memcache looking protocol, HTTP, RPC. We're actually going to be doing this multiple times, running multiple servers, and actually running them in the same process. So first of all, we're going to implement a server which has commands mapping to get, set, and delete. And these are the expected responses. So if you get a value, it should return the value, or a not found. It should acknowledge that you're storing things. And if you delete, you either say it's deleted or it's not found. KeyValueServer.py. This is an implementation. Run this. And have a play with it. Run it and telnet into it on port. I need a better laser. 11211. Is that a standard port? Memcache port. All right. So it looks like Memcache. I think this is actually the Memcache protocol. If-ish.
The store is because in store you have to put how many characters
Length,
you
yeah.
do.
It's length prefixed.
Yep. So run this. We're using line receiver, so it requires /r/n. You can change that delimiter by changing the delimiter attribute. It splits out the line. That is awful, but I guess it fits on the slide. Get, set, and delete. Anyone got that running? It's not hard to get running. Yeah, good. This is a client. So that's a protocol.
This is the same file, it just didn't fit on one slide. So it's cut up, but it's the same. That def is a method of that class.
All right. So what this is actually doing is the client needs to be able to return deferreds because we're going over the network. So when you do several gets in a row, you might have several pipelined. So you need to be able to call it several times, do several sends, add to the deferred, and return that deferred. And then in line received, you need to be able to say, oh, okay, so I've received a value, so I have to do the get deferred callback. I've received a stored, so we do the set deferred callback. And I mentioned this earlier, where you might have a list of them, and you pop out, say the least recently inserted one, so it's a queue. Is that a queue?
Well, right here it works like a queue, but the obvious problem with this is that there are zero guarantees as to precisely in which order something will arrive right now. If your client sends like sets a value and then sets another value, but the second value gets set before the other one, then you'll get stored. Well, okay, for stored it doesn't really matter because stored doesn't give you any data. But like, let's say that you try and get two values, one of them exists, one of them doesn't, right? And you get them in rapid succession. It's possible that the second one, which didn't exist, arrives back at you first, and then.
Fortunately, the server implementation doesn't allow that to happen. What we don't actually deal with, and this is where error handling comes in, is not found and get not found. And those are not implemented. Okay, so we need to have asynchronous error handling. Error backs are just like callbacks. They're for error conditions. They create a chain. So there's a chain of them using back, and they're called explicitly with a reason. Usually you pass an exception object it through as the reason. I'll go into that later. And it's called implicitly when any callback raises. So if you raise an exception in a callback, it will not call the next callback in the chain, it will call the next back in the chain. Backs are generally... Okay, so this is an example of backs here. On success, on failure are two different methods, and it'll say success or failure. A failure object, is a wrapper of exceptions, and it encapsulates a string representation of the traceback, of the error message, and all of that, because tracebacks are expensive to keep in memory. So, because it contains the full stack frame of the whole traceback. So what we do is we copy that out into a string, much cheaper. And in this case, for instance, we create one deferred, we add a callback and an error back, and then we call in 1 second the callback. And in this example, we have a callback and an error back, and we instead call it with an exception. Now, interestingly, this happens after 1 second and 2 seconds, so you see it happening asynchronously. But you could actually just translate that to not even using call later and just call the back directly, because deferreds don't actually require the reactor to run. But that's erback.py. You can run that and you can see the output. You'll see it saying success neat, error bummer. This is not correct. Why is this not correct? What happens when you run this? Run this. Tell me what's wrong.
Well, for one, it's trying to call a deferred twice.
That's it. So what's the error you get? Yes, so already called back. So you can't call an error back and a callback on the same deferred chain because deferreds can't be called twice. So it's important to make sure you only call either one or the other, not both. If you have a callback chain with no backs in it, Twisted won't tell you anything, except on shutdown. Defer.set debugging is a thing which will very noisily tell you, hey, you've got an back sitting here and you've not touched it. Set this when you're doing debugging, and you'll find errors. So there's a common mistake, which is just basically not having an back, and you've got a name error somewhere, so your callback raises. I have no idea what's going on because it's asynchronously in a callback chain waiting for an back to be attached. What happens there? All right, so this is a representation of what happens with, blue is callbacks. So event fire, the first callback fires, calls a callback. Second callback, that returns a value, calls the next callback in the chain with the return value, and it goes down. If you call an back, the back, now, in this particular example, if you're going down the red side, that will only continue to go down the red side if the backs raise or return another failure object. If they return a value, that actually cuts across into the callbacks. So a back is a way of converting failure into success. So for instance, if you had a situation where you wanted to get a page and you're on a flaky network, you might call get page and add an back which says if there was a network error, call get page again and return that. And if at any point you return a deferred, it waits for that deferred to fire before it calls the callback with the value that the deferred. So you can always return a deferred from any callback, and that waits until that callback fires. So in this case, you see, if we take this path down here, we have success. That callback has a failure. That failure tries to converts that back into a success, and we go down. So it provides every one of the flow controls that are provided by try, except, finally, else, in a very convoluted manner. Now, we had a question earlier about inline callbacks, where you can do value equals yield some deferred. What will happen there is instead of doing complicated flow control with deferreds, you can actually do try, except, finally, and all of that will work. But your tracebacks will not look any good. So it doesn't assist with debugging very much, but it does allow for very expressive flow control. Just pointing that out at this point. So here is an example of, a normal synchronous thing. If the result is no, you raise an exception, otherwise you return a result. If you're starting a callback chain for the first time, you either add an back with an exception object, or you call a back with the exception object, or you call a callback with the result. And here's an example of actually calling it. So you do, try print, except print. In this example, on success we print, on error we say something funny. And so we create a deferred and we add callbacks. Now, this is important. Add callbacks. We discussed this just briefly earlier. This adds both of them at the same time. Going back to this slide, that is like adding on success, on failure here. And you see how if there's a failure handled, it doesn't go into the success here, it goes down a level. So, and vice versa. So they're added at the same level. Going forward, if you do add callback followed by add back, it's like this. That's the callback, that's the back. So if an error happens here, or the error happens here, the failure will be called. Whereas in this example, if a failure happens here, it will go down to the next layer of callbacks. That's important. Add both adds both at the same level. So add callback. So it's the same as saying add callbacks to the same function repeated. Here is an example of how to do that. With add callbacks, you're basically doing nothing here and doing nothing there. And in fact, oh no, that's fine because you're returning the failure. All right. This will never happen, except if you're on the conference Wi-Fi. So this is example of, okay, so we're getting a page. On the error we print something that will never happen. Try to find the doodle text, and we raise an exception if it's not found, and on error print no doodle found, then finally print the doodle text. The doodle text on the website. So this is the way you would do it synchronously. You'd open URL, you'd find the text in the HTML, you'd print it, otherwise you catch that exception, and if that raises, then that'll never happen. Sorry, I'm a reliability engineer for Google. It's my job to make sure that doesn't happen. And some of the other examples I use Bing. That's all right. That never goes down because no one uses it. I'm being very naughty. I should not say anything like that. So this is an example of doing it asynchronously. So we create our deferred, getting the page. We have our callbacks. When it's down, when we get the page, we find the text. Blah blah blah, and we print the result. And we add callbacks on page, on down, print result. And that is a graph that looks like this. So in this case, we're actually converting that failure to success with a different message. So here, when we return this, we're not raising an exception. It's not continuing the error case. It's actually converted that failure into a success and provided the value. And then at the end, we always print the result. An alternative would be to have something which prints both failures and successes using add both. Is this the same example? Is this different? No. This is just expressed better. So the different error paths. And you see there's no error path that goes from that error to that error because on Google Down never raises. If that raised an exception, it would go to the next errorback.
The usual case for an errorback going into the next errorback is actually when you have an errorback similar to try except. Your except doesn't necessarily catch all different possible kinds of things that can go wrong. So you have a thing called failure.trap, which is the equivalent of saying, except this particular, let's say, key error, right? But if it's not a key error, then, well, hopefully the next thing in the chain will be able to handle that specific error that did actually happen. So that's like 90% of the cases when you're going from errorback to errorback, it's just because hoping that some other errorback will handle it.
Or when things explode.
Or when things explode.
Is that working? So that's one path, a second path, a third path. All right, so why do we do this? We want to do error handling. We talked about error handling earlier. We said we don't have any way of doing error handling. We now know exactly how to do it. We call d.errorback key error on the deferred. Just like we were doing the other ones, we got the key. This is key value client 2. This is where the code is if you want to run it locally. When we don't find it, we pop the deferred and we call the errorback instead. And we very definitely pop it out of the list because we never want to call it twice because we don't want to call it with success on the next one. Because otherwise that would be bad. So let's use it. So what we're actually going to do is write some web pages which expose the store to the web. We run the store in a separate process, so we're going to use key value client 2 as our client for our server, which is the key value server.py from earlier. That's key value web. This is our index page. And this is an example of how to get parameters out. Request.args gives you your parameters. It does it the very old style of expecting any parameter to be repeatable, so you've got to get the first value out. I'm sorry. I am actually to blame for that. Request.args was mine.
Sorry?
Request.args, that was mine.
Oh, okay.
Yeah. You should have seen what it was before. All right, so this is something which will actually try and get the key, use the key value store to get the key, adds an error back saying it's not found because of whatever reason, then writes that to the web client. So this makes sure that we trap the error and converts it to a success, writes it and finishes it.
The only reason why the server is a separate process, possibly running on some other machine, is just so you can use all of the pieces together. It is perfectly possible to use use a web server and the key value server in the same process, and in fact, that's what you would usually do. So that's actually what we said earlier. One of the nice things about Twisted Web is that it's perfectly possible to have, like, if you want your key value server to respond on Jabber, there's XMPP support in there. If you want it to support on respond on IRC, web, all of those things all in the same process, that works fine. So the only reason we're doing that is so we can show off the client at the same time.
Yeah. So that's the initialization. I can't remember what file this is in. You can probably grep for it. It's one of the key value, I think it's called key value web. But have a play with that. You should actually have get, set, delete and an index page. Pretty sure it's there. Okay, do that now. This example still uses listen TCP.
The next thing is that just spread or amp?
No, PB.
Oh, okay. Nice. Just to convince people that this is a small light library that you want to include in everything.
If I were to do this again, I'd probably actually demonstrate XML-RPC, because that's actually a useful thing that people use. Too bad XML-RPC is awful.
I'm writing a thing that allows you to define amp things and then expose it as JSON or XML protocol buffers.
Protocol buffers. Definitely use protocol buffers.
I still have to write something that compiles
An amp definition to an amp main definition of protocol buffer spec.
but we'll get there.
And then generate the Python protocol buffer. Yep. If you ever do write network protocols, I do recommend using protocol buffers for your on-wire format. Protocol buffers are just an efficient way of going about things. So this should allow you to have a web page which gets sets and deletes out of the key value store, provided you run all the right bits. Here. Actually using client creator in this slide. I think the example in the other one doesn't. Client creator works better with reconnecting client factory.
Right.
I think it works with reconnecting client factory, as opposed to not.
I don't think you can use it with endpoints yet.
Yeah, you can't use client creator, definitely. The nice thing about client creator is you don't have to generate a factory.
Right. So basically, because the pattern of when, like Stephen said earlier, when you're using clients, each and every client that you open probably wants to do something else than the last client. Therefore, you end up creating a factory every time, which doesn't necessarily, well, sometimes it can make sense, but it's just a lot of boilerplate. And because of that, you have a client creator, which just creates a factory internally, and it turns like 3 lines of code into 1 line of code. But
I think the example that you've actually got in your examples doesn't use client creator. I factored that out, but getting the syntax highlighting on the slides was quite problematic. I really need some way of generating slides where I can embed code effectively. Otherwise, I can't actually test things properly. That's how we ended up with those bugs on the previous slides.
HTML. Pigments?
Yeah, there's pigments, there's all sorts of things, and all of them are awful in various different ways. This is one of those problems that's never been solved. Never been solved to my satisfaction.
Fair enough.
Interesting side note, the reason that you can actually plug in a projector and expect it to work on Linux is because, who was it? Keith Packard got so annoyed at conferences that he went and rewrote X until he could do it. True story. Okay, so this next thing is twisted.spread. Perspective broker is what PB stands for. It's inter-process communication for inter-process communication to and from twisted servers. So it's deferred capable, works quite neatly, does safe Python objects over the wire, as opposed to pickles. Never transmit pickles over the wire. Pickles allow you to do arbitrary code execution. They're a security problem. Do not use them on network protocols. So PB is safe. It's an IPC mechanism. There's a more featureful one called fullscap, which you might want to look at if you're actually serious about this stuff. But we're going through this because this is what's built in.
Particularly security-wise, if anyone knows Brian Warner, it's this guy. So yeah, fullscap is particularly in terms of security has very, very advanced features.
SSL and all of that. Yeah. So the idea is that you can define a bunch of methods. You always have a prefix, so you don't actually you can't actually access any private methods. Get set, blah blah blah, and you listen with a server factory of that's supposed to be that. Oh, okay, so you have a subclass of pb.root. In this case, it's called rdict, and we listen using that. And you can create a client, which is a client factory, and you can call remote, get there, maps to that get there, any arguments, maps to any arguments on that, and that can be Python objects in the wire. So you can have effective RPC. This is key value pb.py. So you pass it a store, so you can share a store between a whole bunch of objects. It's got a list of methods, and you see this is just returning store.get, 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 store.delete, and we're creating a server factory. It's got the key value store from earlier, and we create the server, and we listen on it.
Even if that thing happens to return raise exceptions instead of return an actual value, that will also be mapped on the other side.
So you get a abbreviated traceback object and whatnot. And this is a client that goes and this is using. If only this worked. Okay, what is this doing? It's using PB to call remote. So this is instead of using the memcache protocol, it's using PB in order to do exactly the same RPCs. Call remote returns a deferred, so you don't actually have to handle all the deferreds yourself. There's no popping, pushing, etc. It's just calling remote, and so it's all integrated. And in this case, what it does is it after it connects, it calls got root and creates a that site from earlier from key value web and passes that store through. So previously we had that parameterized, so it had its object which went and there was a connection. This, instead of being a connection, is a PB client. And neatly sidesteps a whole lot of issues to do with having to create your own deferreds, because you use calling functions which create them for you and handle errors. And this is the culmination. Key value server 2 listens twice. It listens on the key value store protocol, that memcache-like protocol, but also PB. 2 different ports simultaneously, 2 different endpoints, and we run them, and we can talk to both of them at once. And
I do something like this in production right now. So I basically have an RPC service that, all in the same process, transparently talks JSON RPC over TCP, JSON RPC over WebSockets, JSON RPC over a bunch of things, AMP, XML RPC. I'm probably forgetting something, and it just all does that in the same process, and it all chugs along happily.
I really like the idea of having a web server in every process, just so that you can access status of it, increment counters, see the counters in the web server, so you can health check what your process is doing.
The web server, and also conch manhole.
Oh, manhole
right.
as well.
So manhole is what is basically a remote REPL, a remote Python REPL. So what you can do
is actually identical to this. This prompt where you can interact with the main loop. This is exposing that on standard I/O. It's the same protocol which is used to expose it on Telnet or SSH, because the SSH implementation allows you to wrap up a standard I/O interface, and it conforms to the same interface, and so you can effectively use this REPL by telnetting into your server. So for instance, what I once did in production at a previous employer was we had the ability to turn on debugging for a service. It would generate a password. You'd SSH into the server with the password it generated, and you could do whatever maintenance you needed to do, or do the really intricate debugging you needed to do in order to find out what had gone wrong, and then lock that off again. So you can actually start and stop as the server's running. All right. So, questions? Any questions? We're nearing the end. How much more time do we have?
40.
Okay, so we've got 40 minutes for questions, and I've got a few other topics I'd like to talk about if we have questions about them. So, questions, please. Sorry, there weren't any exercises on this end of things, but running those servers is very instructive.
I'm trying to figure out if it's a really... Oh.
It's more a request than a question. Can you show us more example of inline callbacks?
Inline callbacks. More examples of inline callbacks. I wonder if Big Demo has one. Where's that code? Is it on? Do you have it on here?
You don't have... oh, yes you do.
I have a terminal.
What'd you need?
I need the code which was on the USB key.
What do you need?
The code that was on the USB key.
I didn't take it off.
All right, I'll use mine. I'm just going to plug in my laptop. Which I have to unlock first. 102.4.768. Yep. Just grab that. No, it's okay. So, actually, I think I actually have a slide with more inline callbacks examples. Okay, quickly, how do I access the... Is that 102.4.768? Is that... I don't know if that's right. System preferences. Doop, doop, doop. That's network. Displays. Oh, 800 by 600. How quaint. Everyone remember the 90s? Yeah. Keynote. Get rid of the message from my wife. I wonder if... Oh, okay, so... No. Don't have a good example there. Bigdemo.py. Do I use inline here? Yes, okay, so this is a bigger example of inline callbacks. Syn on. That's actually worse. And this... Look how wide that... I think it was him. Alright. So this is an example of inline callbacks. In fact, this is an example of several things, including some things that we haven't talked about. So, if anybody saw the tornado talk the other day, I didn't get any hands up earlier. This is actually using Tornado's main loop instead of epoll, which is actually using epoll, I think. So, so I'm actually running some epoll stuff in here. I also have here. This is greenlets. Yeah, did you see the stackless talk? So this uses greenlets in order to do one thing in there. And this is an inline callbacks example. So creating a client. So create a client factory, attach that, a protocol, attach a deferred, add a message. We did this earlier in one of the examples. Create the endpoint connect, and then result equals yield senderFactory.d. And then, okay, so now this is something that wasn't in the previous example. There's a callback chain. So inline callbacks client, hey? So if I actually go python -m twisted.conch.standard.io. Oh, hold on. I've got to use the one out of my virtual env. Oh, twisted. All right. So if I import Big Demo, Reactor already installed. Whoops. Doesn't care. I don't care. Oh, actually, that does matter. Okay. Import Big Demo inline callbacks client. What was the API of that? It was...
Anything.
That's not helpful. All right, let's see what happens. Takes 2 arguments. Okay. It connects to localhost. So the important thing is that because this uses the inline callbacks decorator, it doesn't, and it's a generator, it doesn't actually return a generator. It returns a deferred, a perfectly ordinary deferred. If I go localhost 8000, that gives me, that's a big error message. What does that say? This traceback is actually rendered quite weirdly because it gives you the full traceback all the way up to the interactive interpreter, and then where the exception was caught, you'll see this kind of message quite a lot if you use twisted programs. So it's a different traceback renderer. And you see this is where it sends through the argument. Now, what have I done wrong? Endpoint client factories init takes at least 4 arguments to given. This works when I run it. Oh well. But the point is that inline callbacks returns a deferred. You can call yield as many times as you want to yield more values. If we want to catch exceptions, then we just do try except print I got an exception, and that will fire. That will happen when an error raises, right? You can do exception E. That also works. Sorry, not exception, like key error. That also works. And the last value, what will actually be on the callback at the point after the callback chain, you can't use return because it's a generator. You can't use yield because it will try and do the cooperative stuff. So you actually call this method, which stops the generator from executing. I think it actually raises a synthetic exception to do it. It's a bit ugly. But you just call defer.return value, and this is the end of the callback chain. And if you add a callback to calling this method, then that will be got R back. Percent R back will be the value that's returned.
If you don't use defer.return value, just get none.
Yeah. Yeah. So if you get none out of that, you have to think, well, you can't use return. You have to use return value. It's a bit ugly, but it works. I'm also going to show something else, which is a bit weird. Coroutine.
Do we have to?
Handle connection. See this? This is a method, handle connection. It gets passed to transport. We're buffering lines. It's a method thing we import. It says full line in transport, transport.writeLine. So this is an echo server. This is an echo server that looks synchronous. But because it's done using coroutine, because of greenlets, listen TCP, glisten TCP, that's the greenlet listen TCP, actually makes it so whenever you try and get information out of the transport, there's no information there, uses greenlets to return control to the event loop. This is really nasty. But it works. It works surprisingly well. There are a few bugs to do with exception handling and network conditions. But if you want to just quickly throw some procedural code into a twisted thing, it might be useful.
This is basically the equivalent of gevent, except instead of libev or libevent, it uses the twisted reactor.
Yep. Okay. So would you like more examples? Okay. Oh, testing. We didn't cover testing. Let's actually talk about that quite quickly. I got a slide here. So this is a nose test. You know what? I updated the test slides the other day and then I lost all of this stuff. So this is using nose test.twisted util. It's got a decorator to say you got a timeout of 1 second. So this test if this test doesn't fire success, then it's a failure after 1 second. It goes and actually connects to a server, creates a client factory, connects to a server. Does this actually connect to a server? No, it doesn't. See, this is entirely synthetic. It doesn't connect to a server. It plumbs in the it creates a protocol instance, plumbs it into the factory, and then actually calls line received directly. This is an entirely valid way of testing twisted protocols. You don't actually have to establish a TCP connection. You can actually just call line received or data received with a line ending on it, and that will work.
For larger twisted projects, what I tend to do is I write functional tests that actually create a real server and actually create a real client and do real I/O in between them. And then in order to get those to pass, you write a bunch of unit tests, and in unit tests I do zero I/O, no disk I/O, no network I/O, no nothing. Just mock everything out, and as you can see here, very often you don't even really need to mock anything out. Once in a while, it's usually transport that you have to mock out because things called transport.write or transport.lose connection. But so basically, yeah, just you can write unit tests very easily that don't involve any real I/O.
The biggest trap you get into when you want to write tests for twisted code, you think, how do I connect two protocols together? How do I actually create a connection? And then you realize, oh, you don't actually have to. There is a loopback transport, which is useful if you actually want to do this, and allows you to do it without actually establishing any TCP connections. It stops any isolation failures. This example shows an assert. So you're actually asserting that it failed. And whenever you unit test with twisted, you can return a deferred, and that should fire with either success or failure or timeout. This is nose tests. There is also a tool called trial, which is twisted's own unit test runner. You've got to use a test runner which is deferred aware. So nose tests with its twisted capabilities or trial are the two main ones.
As long as you use twisted.trial.unitest. So basically inside trial is a version of unitest which unlike regular unit tests, it adds a couple of assertions, but unlike regular unit tests is deferred aware. As long as you use the deferred aware code, you can use whatever test runner you want. I think even the pi.test one works.
Okay, so so this is a trial example, and this is in the sample. So you actually run trial space test sample.py. This is a complete example. It works. It actually goes to Twitter and makes sure that Twitter comes back. That'll happen maybe once and twice, so it'll fail quite a bit. This is nose.twistedutils. This is exactly how to do it. So this is where you get the deferred there, and you actually get a reactor, which is a mock reactor for testing. And you can run nose tests on test_nose.py. We didn't talk about threads much.
I was just about to say that we didn't talk about threads and cooperation, so maybe I should, I don't know if you have a slide for that, but I can just talk about that if you like. So we said something, we've been talking about how you're not allowed to block the reactor, and there was the example with URL open that just read and did some synchronous I/O, and that blocked the reactor, and then you couldn't do anything else in the reactor. You're not supposed to do that.
So often you need threads. There are people who religiously say you shouldn't use them. They are useful. They are needed. So whenever you do database operations, whenever you do name lookups, you might not realize this, but there isn't actually a asynchronous DNS client that works. There's a lot that pretend to, but there's not actually one that does work. You've got to use get_info, which uses all sorts of crazy stuff. So you have to do those in threads, and Twisted does do them in threads, using a thread pool. In this case, we've done from twisted.internet import threads. I think it's twisted.internet import threads, and that has this method defer to thread. It's a great method. That creates that goes and runs a thread which calculates the nth Fibonacci number, and you always put in 1,000,000 there, and that takes forever to run. That'll run in a thread, won't block your reactor, and when it's finished, it will in a thread-safe manner call your callback within the main thread. So in this case, it goes and runs Fibonacci and then replies on the web server without blocking any other.
So basically there's two ways of getting around the blocking thing. One is block somewhere else, so run in a different process, or as deferred to thread does, run in a different thread. There's the other option of cooperatively working, which is if you can describe the CPU, this can be CPU-intensive work. If you can describe the CPU-intensive work that you're doing as a generator, and you can say, like, okay, I'm going to do some work, and then I'm going to yield. And then when you're ready for me to do some more work again, I'm going to yield again. And as long as I promise to only do a tiny amount of work every single time and not block the reactor, then that works fine. And in twisted.internet.task, there's a cooperator, I think it's called cooperate. There's a function called cooperate.
Yeah.
There's a class called cooperator, but you generally want cooperate.
Yeah.
And essentially that does exactly what I just said. So it will call a generator and expect it to return within a reasonable amount of time, whatever that is for your application, whatever it is, it's small, and it will continue calling it until it's done.
So cooperator is nice because you don't have to worry about thread safety, no locks, and you've got the GIL anyway, so it's not like CPU-intensive stuff isn't going to block the execution anyway. You just do it in small blocks. I should mention that when you are in a thread, you're not allowed to call methods which will actually do any I/O or talk to the reactor. The only Twisted API which is thread safe, which is defined to be thread safe, is a method called reactor.callFromThread, and that inserts in a thread safe manner something into a queue for the reactor to run on its next loop. And that's a thread-safe way of and it works on every reactor, Windows, KQ, IOCP, select, to, in a thread-safe manner, call things from threads in the main thread. If you want to spawn a thread and just run one, you can. That's completely allowable. If you use things like defer to thread, it uses a thread pool. That thread pool is available in Twisted Internet threads as well. You can create multiple thread pools, so you can have one thread pool for this worker, one thread pool for that worker, so you don't have one exhausting the other.
That's how the database, Twisted.enterprise, the database, relational database APIs at least work. They create their own little thread pool and talk synchronous, use the synchronous like MySQL or Postgres client commands.
What other information? We also have in the TX project a deferred a process which is available. That's in, I can't remember the name of it, but deferred a process does exist, I assure you. If you Google for it, you'll find it. And that does the same sort of thing that multiprocessing does. It spawns a process, has a process pool, will communicate via pickles to the subprocess and run code, then return the data via a pickle.
If you just want to quickly run a process, there's already on the reactor there's reactor.spawn process. The nice difference between that and multiprocessing is, I don't know if anyone's ever used multiprocessing and tried to do standard I/O with the subprocess and both listen and write to that thing. If you're doing that, especially with multiple processes, it becomes incredibly hairy, and the only way to, you can't even, actually, as far as I know, in Python 2.7, you cannot do it correctly without involving select and basically rewriting Twisted. You can do reactor.spawn process, you get a nice process, it is a protocol, it gets like data received, and you can do self.transport write, and it behaves exactly like that. So if you write a protocol, like the many protocols that we've written today, and you want to speak that with standard I/O with some subprocess somewhere, that works fine. It's really easy to do.
Lawrence isn't quite correct. With subprocesses, you actually have standard error received and standard out received, because there's three, not two. But almost.
Enough.
It's enough, and it's useful, and the protocol is well defined. So that's talking to threads.
Actually, just use data received on it, but then it just doesn't. I think data received gets called for both. Anything that comes in on standard out is standard.
So another thing which is kind of nice is being able to run a process as a daemon with logging to syslog and all of that kind of thing. And being able to, on a command line, specify which reactor to use. So the technique we use for that is called a plugin. Like this is an example of a plugin running. if I go out here and twisty minus n for run in the foreground, web.
You need to specify path.
No.
Oh, really?
That runs a web server. So localhost 8080. Hello, this is a twisted test page. And, you see HTTP logs and all of this. And if I actually go minus help on that, it says, you can specify a path, you can do all sorts of stuff. You can say don't do tracebacks, do SSL, this is my private key. This is the port to listen on HTTPS. So this is a nice way of spawning a plugin using the twisty command line. Now, this Bitbucket repo is something I wrote last year because I found that it was very hard to find an example of actually how to write a plugin. Writing a plugin is very useful. It allows you to take command line arguments. It allows you to change on the command line how you do all your logging and all of that. And that's just a neat way of packaging it all up. So that's just an example. It runs an example server. And I think I have a branch there that uses opt parse instead of the twisted options parsing as well. So you can do whatever option parsing you want as well if you're comfortable with G flags or opt parse or arg parse or whatever.
Next time you're at some relative's house and you need to transfer some files desperately off of your laptop onto theirs, and it's some wonderfully misconfigured Windows machine, or you have a Mac and they don't, or you have a Linux machine and they don't, twisty web. You have a web server. Everything speaks HTTP. I'd be very surprised if you manage to find a relative that doesn't have a web browser.
So here is serving a particular directory out of it, and it just works. List of plugins that are built in. Conch, Procmon, Manhole, Mail, DNS. So running a caching DNS forwarder is a matter of twisty minus n DNS. Let's just check the arguments. So whether or not you want to cache, whether or not you want to recurse, the host file, the resolve conf, zone file, this is a little easier than setting up bind as a caching.
I was just going to say, anyone who has configured bind will find this significantly easier.
If I want to run it as a daemon, I remove the minus n flag. What are the other options on this? You can change which reactor to use. You can make it daemonize. You can use whatever UID, GID, syslog, effective user ID, log file to log to, etc. All right. The first mistake you'll make is forgetting to use minus n. It'll just return like that, and then you'll actually find twisty.pid. So you cat that, and you say, that's the PID number, and so you kill. That's the incantation. Sorry, I always do that, and I always have to do that. It's a little thing, but
Use backticks.
Use backticks?
Yeah.
I always use $open. Actually, no, I don't use $open anymore because I use fish normally, not on my laptop. But everyone, has anybody here used the fish shell? I don't recommend it, but I love it. I can't recommend it because it's not Bash compatible, and so all the things that you know from Bash aren't there. This is other stuff that we've got. Manhole we've mentioned. Launchpad.net/tx. Third-party libraries are generally called TX something. So TX MySQL, TS PGSQL.
Thievery.
Hmm?
Thievery, my PayPal.
Oh, his PayPal twisted thing is called TX Thievery.
No, just thievery, but with
Oh, really?
yeah, just thievery.
Oh.
But with an X.
X's do not make things cool, Lawrence. More resources. That's the GitHub repo where the Twisted training materials are. TwistedMatrix.com, of course. My plugin example. JP Calderon is a Twisted developer. He is a magician, and he has written a series of web in 60 seconds, conch in 60 seconds, small tutorials. I recommend if you're interested to go and read through those tutorials. He's on Asynchronous. Is his domain Synchronous us.
Can you check that? Because I could have sworn it was a.synchronous.ua. It could be. If it doesn't work, it's the S is on the domain name.
pretty sure that's right.
Okay, I could be wrong.
Let's find out. I'm editing. Woo!
Okay, it works.
All right. And picture of a cat. All right. Any other questions?
Did you mention what the Crondo thing is?
Crondo, that's another tutorial.
Right, so yeah, the Crondo blog tutorial is something that I personally like very much, and eventually, now it's actually on the Twisted documentation page. It's one of the only links that we have to outside of the Twisted page itself. It's in scope quite similar to this tutorial here, although eventually he ended up going way past that. But he also explains like deferreds from scratch, event loops from scratch. So if you want to read up on anything of that sort, you probably want to look at the Crondo blog tutorials.
All right. I hope we haven't lost too many people. This has been a bit of a whirlwind through how to actually write protocols and whatnot in Twisted. Any other questions? Sure. If you say it, I'll repeat it. Yes, the slides will be up on files.ep. They'll be up there afterwards. So the question was, will we have slides up? They'll be up there. Sorry, another question? Okay, so the question was, what do I think about gevent and Tornado, and how do I differentiate? There are many network protocols already implemented in Twisted, and that's one of the reasons why I go to Twisted immediately. For the 0.15 release, we had a big sprint to try and get as many protocols implemented as possible. So that's one thing that's really great. Now, gevent is nice. I've got nothing against gevent. We actually have coroutine, which is a gevent style, which you can use within a Twisted event loop, and that's pretty neat. Tornado, I have an example here. It's actually in the example files, bigdemo.py. So Tornado, you can actually use the Tornado event loop as a reactor. And then you can use whatever Tornado code you want, and Tornado is a nice little web server. It's a nice little web server that allows you to do nice web server-y things, and you can use that with Twisted. And so you can go and do your XMPP server at the same time as your Tornado server, but it's harder to get the network protocols running in Tornado if you want to do fancy things. I also did look at Tornado, and one of the things that I found was not so good was error handling with callbacks. And so I like Twisted's error handling with callbacks better. Do you have anything to say about gevent?
With regards to gevent, for example, I've used gevent. I played with it. One of the things I don't like is the monkey patch the entire standard library. I understand why they do it, because it supposedly magically makes anything that is currently blocking non-blocking. It's nice, but then it's not nice when you have, like, for example, a C library, a C MySQL or a C Postgres library that you can't magically make non-blocking. I don't like the idea of monkey patching the standard library. I understand why they do it. Another reason why I like Twisted is if you start with the callbacks, they're a strictly stronger model than one-shot coroutines. You can express, well, we demonstrated inline callbacks. You can express synchronous looking code like that with inline callbacks, and internally it uses regular deferreds and callbacks. You can express coroutine style things, again, evidenced by demonstration, coroutine. So you can express those models using Twisted. You cannot easily express the other way around. So if at any point in time you end up with some code where callbacks actually make sense, and gevent proponents will say there are no examples where callbacks make sense. I disagree. I think there is code that you can make significantly nicer in callbacks. There is also code that looks a lot nicer in synchronous looking. I will happily admit that. For that, I use defer inline callbacks. I don't use courage one anymore, but yeah, I just use defer inline callbacks when synchronous looking code makes sense. I use callbacks when synchronous looking code doesn't make sense.
So for instance, the other day in the Tornado talk, I did ask the question, how do you handle threads? Tornado doesn't have the facility to handle threads, so if I was in a situation where I had a Tornado code base and I wanted threads, it would be very easy to say, also run the reactor, the Tornado reactor, so it's the full Tornado stack is running, but I also want to be able to have my event loop from Twisted. Sorry, not my event loop, but my thread pools from Twisted. I can do that. I just import the thread pools and start using them, and then suddenly I've got a good abstraction for thread pools in the same context as my Tornado program.
On a similar note, let's say that you have some computationally difficult thing that you wish to run. For example, the example that I currently use deferred thread the most for would be a key derivation function for securely storing passwords. Now, by definition, a key derivation function is expensive to compute. Also, it's going to be in C because it's heavily vetted crypto code. You don't want to rewrite that in Python. You certainly don't want to rewrite it in a way that it becomes cooperative because you're going to leak. I mean, the option for introducing security problems is the attack vector space there is just so large it's impossible to do. So what do you do when you have something where you really have something that really needs to block? In Twisted, I called reactor deferred thread. You have all the problems with threads, but fine, with reactor deferred thread, at least I have a defined way of doing what I want. With gevent, to my knowledge, I could be mistaken if there was something written for that now, but I remember talking to Dennis Belenko last year at EuroPython about this, and there was no way of doing that. So I could be, I haven't checked gevent recently, so I do apologize if I'm spreading lies now about the current state of gevent.
Okay. Any other questions? All right. We've got some of those late. Oh. Easiest thing to do when I've done this is.
Can you repeat the question?
So the question was, say you have a big program, and it's not using Twisted. It does a whole lot of stuff, but you also want to suddenly use a Twisted protocol in the middle of it. The easiest thing to do, and I have done this, is you start the program slightly differently. You import Twisted, you import the reactor, and you call reactor.callinThread, and you call your main function from your original program. And then from there, you can call reactor.callFromThread to start things in the main loop. So you have a simultaneously running main loop and your program. And in your main function, you have a try except around the whole thing to say, when I shut down, I also want to call reactor.stop. I've done this. It was very effective. It allowed me to simultaneously have a program which had a big legacy code base, and then I had access to the main loop. I was able to go do stuff in the main thread. I think is there a blocking call from thread now? Yes, sorry. There is a second API. A blocking call from thread is a way of saying call from thread, so call in the main loop, and block on whatever deferred that returns, and block the thread until it returns. So you can sort of have a thread which has a blocking API available in the main thread. Yeah, it's very effective. You have to do some fiddly bits to make sure that your program stops, but I think we can deal with that. That's an intractable problem sometimes.
I had a similar experience, except I did the old program in a separate process, but that was mostly because it wanted to do things like signal handling, which under most platforms, if you're not in the main thread, is basically undefined. People do it anyway, and then it breaks 6 months later for no apparent reason. But yeah, separate process, IPC, separate thread, blocking call from thread.
Okay, so there is actually a problem here in that what happens is that the signal is delivered to any thread that is currently running. Sorry, the question is about, to do with signals. Is the signal delivered to the main thread or other threads? At least the situation was last time I looked at this in great detail, was a signal will be delivered to your process. It will be delivered to the currently running thread. Python will then set a flag to say a signal was delivered, this is what the signal was, and the next time the main thread wakes, it will see that, and instead of executing the next bytecode, will then go and execute the signal handler, and then go back and continue executing bytecode. Where this breaks down is where you are blocking in a C API. This happened with GDK. GDK would be the event loop, and you would register your file handlers with that event loop and then call back into Python code, and so you were not executing any Python bytecode every time an event occurred until it actually executed one of your callbacks. So what would happen is you would get delivered a message to a non-main thread. It would not interrupt the main thread. The main thread would be stuck in its poll or its select until the next event occurred. Then, as soon as the next event occurred that actually touched Python, because GDK, moving the mouse, does not call callbacks into the Python code. It's only when you have file descriptors. It would not call that callback until such time as that thread woke and run Python code. There are even race conditions here where it can happen with select. So the way they fix that in the GDK case is with PyGDK, because people do heavily threaded stuff with GUIs. It makes sense. Is that they poll with a timeout of 0.1 seconds. So you're intentionally waking your process every tenth of a second, which is not very good for your laptop staying asleep. Signals suck.
I think there was another question.
Oh, there was another question? No, all right.
No, not anymore.
But what's a project you've been working on lately?
So that would be work-related, and it's essentially a giant twisted project that this is actually a good example of where blocking API, where blocking is really a relative term. And when people say blocking in a negative way, they mean blocking too long. At the end of the day, if you're adding two numbers up, you're blocking. There is something somewhere that's doing something, and you're not allowed to do anything until it's done. It's just that adding two numbers is really, really fast, so you don't really care. In my example, we use SQLite database. Well, actually Axiom, which is a project in the Twisted ecosystem, I would say, but it's not really Twisted specific. It's an object database. So it's essentially a very, very simplistic ORM. It fits in your head. And it uses a real on-the-disk SQLite database, and it does all sorts of blocking operations on it. But that's fine because it's local SQLite, and I try to make sure that I don't do incredibly expensive operations on it. And similar to another project in the Twisted space, we have like one SQLite database per user. So one SQLite database never really grows that big. So any query is going to be returned within a millisecond, so nobody cares. And this is the thing that I was talking about, that within one process, I have one definition of what a certain RPC method semantically means, but you can do that over JSON RPC. I do that from a browser. I do that from an AMP client. I do that from XML RPC. I don't do that from SOAP because screw SOAP. But if I really wanted to, I probably could. So yeah, that's what I do. All right. You can't talk about how Google is dominating the world with Twisted, can you? No?
I don't think that's a question which has an answer. That's not
officially
a goal.
Not, at least, right?
That's not a goal.
To give you an idea so many people are somewhat surprised when they find out apparently what sort of companies use Twisted, but there's big brass using this stuff. For example, Industrial Light and Magic, so the people behind Star Wars, and a number of other special effects for recent movies, they run their entire render farm on Twisted. That's not exactly a small hobby weekend project. NASA uses Twisted in something related to the Mars rover. It doesn't actually run on the Mars rover, unfortunately. And Spotify, so big sponsor here, Spotify, at least a year ago, was essentially a large Twisted app with some C++ into it for the slow parts. So there are very, very serious people using Twisted.
I should say that the Windows support of Twisted is absolutely phenomenal. I was running it on probably about 40,000 machines, and I got to see every exception that was raised, and there were very, very, very few, and it was usually because the machine was crashing. The Windows support, thousands of simultaneous connections, actually processing data, good support, running as a service, the whole thing. That previous job, not Google.
Twisted is botnet proof.
Sorry, yes.
We will ever see Twisted running on top of
So
yes.
This is, I believe,
So the
well,
question-
it's possible that I did this during the break. I don't remember, but yeah.
The question was?
So the question was, when will Python run on Python 3? When will Twisted run on Python 3? So we currently have a Google Summer of Code student whose job is essentially make it work. Antoine Pitrou, the CPython core dev, has a fork of Twisted where he apparently gets, and like a very large majority already works. There are some parts that are very annoying. Primarily, so Twisted has a thing called twisted.python.filepath, which is an abstraction over file paths, because using strings is really, really bad. But then you run into the issue where on Python 3, Python insists that a file path is Unicode. Now, you have an Ubuntu sticker. I'm assuming that means that you're also running Ubuntu. Your file paths aren't Unicode. Your file paths are bytes. And so we have fairly extensive testing to prove that file path works on both Windows and Unix, despite the fact that they have completely different semantics about what exactly a path is. And making those work on Python 3 is very hard because Python 3, the tools that you have in os.fdopen, for example, or os.path, they don't arguably do the right thing. So it's very hard to get that right. Then there's some issues with trial that have been fixed now because unbound methods don't exist anymore in Python 3. There's tiny issues here and there. And then the final issue is the last two issues are old style classes because some of these classes were literally written for Python 1.4. And finally, things like FTP that are from the 70s. And although, so Python 3 likes to be very, very strict about what is bytes and what is Unicode, which is fantastic. Except the problem is there are things that are not strict. And sometimes when you get bytes and you're dealing with a protocol like FTP that decides to spew the output of some incantation of ls on BSD 4.4 onto the wire, that's bytes, but you have to edit it. And I don't know if you've ever used bytes to try and do string manipulation, but it's not pretty. So then you have to encode it into Latin 1 because that maps every byte sequence into code points, and then you have to do it on that and pretend it's Latin 1 and then decode it back in. It's very, very ugly, and that takes a lot of work. Basically, we're in the same position as Django. It's a very, very large roadmap point. There is no, unlike Django, we're not saying the next release will have it. There is very hard work being done by our GSOC student. A lot of kudos to her, I believe it is. But it is certainly a work in progress. Big leaps are being made. A lot of it already works. So basic TCP works. SSL works as long
As of-ish now.
Yeah. SSL sort of works, and the majority of protocols, because they're not the majority of simple protocols, because they're not incredibly complicated, work. It's not officially supported yet, but I'm not going to name a date because then I'm afraid that I'm going to jinx it. But I would say that in the near future, probably before Python 3.4. But probably after 3.3, since 3.3 is being released next week or something, it will work.
It'll probably only work with Python 3.3, but
Yeah,
that's the
3.3
price
and
we
above.
pay.
Mostly because we need the bytes in Unicode, the explicit bytes in Unicode thing, because we're probably going to move to so previously the idea was that you would use a code base for 2.x for existing projects, support them to 3, use a code base for 2.x, and then use 2 to 3 to make it work on 3. That has fallen somewhat out of grace in favor of trying to make the code base work on both. Although that has obvious issues, like for example, dict.items does something else on 3.x versus 2.x. But anyway, that's the current plan now, as far as I know, and so it will only work on recent 3s. But by the time it launches, nobody will. Well, okay, no, Red Hat will be running 3.1 or something, but nobody will really be running 3.2 anymore. So
yeah. All right, I think we're more or less done. If you have any more questions, then feel free to ask afterwards. And thank you very much for being so patient with us and the good questions.
I've got cards on me if anyone wants to get in touch with me after the conference. So.
All right.
No, just would like to make more remarks. Please pay attention because there were some other additions and moving around of talks, so just have a look at the schedule because there are some changes if you are interested in the afternoon talks. Thank you very much for attending.